Hi, everyone. In this session, we are going to start with a new series about the software refactoring patterns. At first, this series will be maybe easy for you, but there is another series in the future which will be about the software anti-patterns. So we will talk about software anti-patterns, and then we will try to refactor that anti-patterns in order to have a more clean code. So in order to refactor anti-patterns in your code base, you need to know the best practices, the good techniques, and the good tools in order to reach that kind of clean code. So we will start the refactoring pattern first, and then in the following series, we will talk about the software anti-patterns. So until now, we have talked about the DevOps topics mostly, but why this refactoring term is important to us? Because in order to have a good DevOps mindset, you need to have some strong skills about software development also. If you are doing this in a good way, you will be very good at both on the software development, and then you will easily to end of environment by using some DevOps text. What is refactoring here? It is the strategy to eliminate technical debts. So it helps you to convert the legacy code into clean code. So if you are trying to refactor something, actually you are trying to reduce your cost, because the more clean code you have, you will have the much you reduce your cost. Okay. So what is clean code in a way? If you are implementing your code base by using clean code techniques, you will have a readable code base for every programmer. So it will not have software anti-patterns because you are doing the refactoring, or you have some clean code practices in your code base. And if you have clean code, it will be very easy to maintain. Let's say that if you want to add some feature to your code base, it will be very easy to do that because you have clean code. Technical cost is something like implied cost of a rework will be done in the future caused by choosing simple solution instead of best practice approach. So let's say that you are doing you are implementing a feature in your product. So in order to finish that in a small time interval, okay, you can do that, but that time you may have some bad practices on your code base. But if you use some clean code practices, you will have less technical debt in your code base, because if you do not use some best practices in your code base, you will need to refactor that part in the future again and again. Most probably this technical debt caused by the lack of tests. So if there is no test, you will not be able to detect any kind of bug on your system whenever you add a new feature into your code base. Business pressure is also another option. So you have a large pressure coming from the business side. So you need to implement a feature in a restricted time interval. So that will also cause the technical debt also. Weak inter-team communication here. So let's say that you have 15 teams in your current company. So if you communicate that team in a good way, let's say that if you review your code base by using the different team, so it will be very easy to detect any kind of bug on your system, or you will have lots of options to refactor your code base, again, coming from the other teams. And finally is the postponed refactoring. So if you do this, okay, I have no time to refactor this one, I will do this in the future, so I need to add this feature right away. So that will also cause technical depth in your code base. When do you need to refactor your code base? If you are adding a new feature, okay, you can refactor that one, because let's say that if you are adding a new feature, most probably you will use the existing functions, existing classes from your code base. So you may refactor the existing code base during your new feature implementation. When fixing a bug, so in order not to produce another bug, you may think refactoring your code base during the bug fixing. Okay, let's say that, for example, there is a null pointer exception candidate in your code base. You can refactor that one during the bug fixing. According to me, most of the refactoring patterns done in the code review parts, because any code base in your code base may not have some kind of bug, but there can be some bad practices there. During the code review, you can suggest some kind of best practices in order to apply that refactoring patterns. So the code review is the best time to refactor your code base during the development lifecycle. Here in this session, by the way, there are lots of refactoring patterns. I am mostly influenced by the book Refactoring Patterns, written by Martin Fowler. But there are a couple of other books that I have provided some help. So there are lots of refactoring patterns used in our terminology, but in this session we will do 5 of them. The first one will be the extract method. By the way, these refactoring patterns may be easy to you, but again, I am saying that there will be lots of other refactoring patterns, and all of them will help us to detect software and type patterns in the following sections. In the extract method refactoring pattern, the actual problem is you have code fragments that can be grouped together. So in order to eliminate this kind of problem, you can convert that code fragments into a method with a meaningful name. Once you do this, you will have more readable code. There will be less duplication, and also there will be independent isolated code parts in your code base. Let me provide you an example for this. So, in order to work this kind of patterns, it will be better if you write some test for your code base. So this is a Spring Boot application, simple REST application here. So I have some product service class here, and also I have written some test for this product service. And let me check if this works or not. You need to check your tests right after your refactorings. So it will be better to validate your, to be sure that you are not destroying your business logic after the refactoring. So we are passing our tests. Here, I am simply getting some data, product data by ID, by using the repository, JPA repositories. And if there is no such a product, I am throwing an exception, product not exist exception. And then once I got product data from the database, I'm trying to convert that data into a product DTO in order to serve that data into user. So for the best practice, we do not show the actual database object to the user. Instead of doing that, we are using some conversion methods, like converting your business model, business object, into the product DTO here, DTO object. As you can see here, I am trying to create product DTO here, right in the get product function. And let's say that you have another function which is called create product. And in that function, you simply create a product by using repository classes. And then right after that, you are trying to return created product to the user as a DTO object. So most probably you will have that conversion method in several places, right? So this is something like conversion. So it will be better to extract this method into another one instead of doing something, doing the conversion things right in the functions here. So you can simply select your function here. I am using IntelliJ IDE here, so I will show you, most of the time I am using shortcuts, but let me show you the menu, how to do that. When you right-click on the selected code piece, you can select the refactor and extract here as an extract method. There is an important part here that if this kind of function used in several classes, you can extract this method into a utility class. So by doing this, all other classes will be able to use this function to convert some product into product DTO. But since this function is only used by this class, into the existing class as a private method. Get something like a meaningful name, so get product DTO here. And it will have product business object as a parameter. When you do this, you will have conversion into separate function here. So let me rerun our test if it's fails or not. Okay. And also, by doing this, we will reduce the line of code inside the function. So in the software and type pattern section, we will see something like long method. According to some standards, there is a minimal line of the specific function, which is something like 30 lines. So more than 30 line, if your function has more than 30 lines, I can say that, okay, that is a long method because it has several lines. By using this extract method, you will have less lines, so there will no long method and type patterns there. So this was the extract method. Let me continue to another one. So, inline method. This is the opposite one of the extract method. So you can put some function-like code pieces into one-line declaration here. So here, method body is more meaningful than the method itself, and the solution is replace the method usage with its body and delete the method. By doing this, you will minimize unneeded methods here. So let me provide an example for this. Okay, as you can see here, when you analyze this one, I already refactor my method here. So, and when you have a look at here, in the product DTO conversion part, there is a field which is called sales status here. During the conversion, I am using a function which is called more than 100 sales here. So this is simply getting the sales count of a product. And if it is something like larger than 100, it will return true. So when you have a look at this method body, you will see that the method body is more meaningful than the method itself. So instead of using this kind of names, more than 100 sales, you can use this as inline method here. So in order to do this, you can do something like this. Select this one, and also in the refactor menu here, and then inline. So when you do this, you will have lots of options here. Inline all and remove the methods. So this is the default one. Do the refactor. Okay, as you can see, I eliminate the method here, and then I use the meaningful version of the this expression. And also, do not forget to run your tests again in order to eliminate bugs or not to destroy your business logic there. Okay, that's cool. So the extract variable here. Let's say that you have an expression in your code base, and the problem is hard to understand expressions. In order to eliminate this one, you can put the result of expression into a variable to use in the expressions. I think you already use this one into your daily development, but the main advantage of this one is they convert complex expressions to more readable ones. This is very understandable. And putting the expression result to a variable with good names will let you to define main reason of an expression. So let's say that you have a complex expression, and when you have a look at this one, at first sight, you may not understand the exact reason why of this expression. So by extracting this expression into a variable and put a meaningful name into that variable, will let you to understand the main reason of that expression. Okay, so I will provide another example for this. So this one, the extract variable here. Okay. When you have a look at here, you will see that in the if expression, I have several, in if condition, I have several expressions here. First of all, I am checking the expiring day of the product, and also I am checking if this product is forbidden or not. Okay. Instead of using this kind of long expressions, you can do something like this. For example, this one is for checking the expiration. So I can select this one, and then I can extract this one into a variable. For example, is expired. And also, this is for the checking if the product is forbidden or not. So I can, again, use the refactor extract and variable. So is forbidden. When you do this, you will see that the expression is more readable, is expired, or is forbidden. So by the way, you can use the utility classes in order to put this one into a more general functions, but it is another term. I'm trying to express here using the extract variables pattern here. Let's say that these expressions is only used by this method, so it is very best practice to extract these expressions into a variable scoped by the current functions. Okay, so after doing this, let's run our test again. By the way, for every refactoring pattern here, there is I have written a test, so it covers the entire business logic there. Okay, cool. So what is inline temp? Temp variable that is assigned by a result of an expression. And here the solution is replace variable with expression itself. So this is something like opposite of the extract variable. The main advantage here is improves the readability. So let me provide an example for this. So here, as you can see, I am trying to, right after product data retrieval from the database, I am trying to convert the data into product DTO here. So instead of using the local variable here, you can eliminate this one and then use the direct conversion method here. For example, as you can see, IntelliJ IDE also warns us about the local variable is redundant. So in order to eliminate this one, you can use option enter and then inline variable here. So when you do this, you will see we are directly returning the expression itself instead of declaring a temporary variable here. So, and also we need to convert this one into more general function in order to do conversion into another function. But again, it is another term. So I am trying to show you the inline temp variable here, eliminating one. What is the next? So this is the final is replace temp with query. The main problem here is temp variable that is assigned by a result on expression, and the solution is move expression into another method to use in several methods here. So the main advantage is more readable and reduce the code duplication here. And let me provide you another example here. Okay, here, as you can see, we are doing that. We are trying to assign this one into a variable first. So what if we use the direct function instead of using this variable assign? For example, you can do something like this. We need to extract this one into a several function first. For example, what about base price? I can do something like this. So base price will return double. And I will use the product and the quantity here. Maybe I can also use, let me do something like this instead of doing that. At first, I will do something like this, base price. When you do this, you will extract the method here. So the main purpose here is eliminating this one and then use base price here. So instead of using local variable assignment, you can always use the base price query method here in order to use in a standard way. Once we execute our tests, we need to be sure on it is working correctly. Okay, this was the final one on the refactoring patterns. As you can see, they are very easy to refactor during the daily development. In the next webinar, we will talk about another refactoring patterns, which is harder than this one. So if you have any kind of question, you can ask, so I can happily answer your questions. If you have no other question, we can finish here. Okay, I think there is no other questions. So thank you for your time and see you in the next webinars.